Hello again everyone, welcome back to ptet.chemistry channel. So in this restructured format of the tutorials, I will not show question paper. Instead what I'll tell you is 9701. So it's an A-level chemistry paper. This is for the June 2021 or the summer 21 session. This is a paper 4. Variant 1, so it's a full A-level paper, which is why it's one of the longer paper, and the duration of this tutorial for paper 4 is usually exceeding 3 hours to 3 hours and a half, and that's typical because I talk on concepts that are related to the question as well, but I'll try to move on as soon as I can, but not at the expense of going through questions and thinking about the underlying concepts and the associated concepts that I think are important on answering the question. Before I start, there's a button on the bottom right to all the videos on the channel, so don't forget to click the button to subscribe to the channel, and turn on notifications so that you get notified of all the latest videos. Follow me at ptet.chemistry, that is at ptet.chemistry on Instagram, Facebook and Twitter to get connected, and please share the channel widely with all your friends, chat group, juniors, seniors, teachers, relatives and whoever else you think the channel might be useful for. So do help them by sharing the channel widely. Let's get started. In this question 1, we have a group 2 chemistry. This is a 3-mark essay question. Essay in the sense that you can actually prepare for it. This is slightly different. This is about thermal stability. So usually when they talk about thermal stability, they talk about thermal stability of group 2 carbonate as well as group 2 nitrate. Those are in the syllabus. But this one is group 2 hydroxide. So M2 plus, M2 plus and OH minus. So you do actually need 2 of the OH minus to balance out the charge from 1 of the M2 plus. What they've told you is this thermal stability is similar to the thermal stability or similar to that of group 2 carbonate. So I know about the group 2 carbonate because there is expected in the syllabus. So what I can say is I can explain first. Down group 2, there are more field in a shell. So if there are more field in a shell, what we can say is that the size, the ionic radius of the M2 plus cations would increase, and when that increases but the charge remains +2, so what happened is the charge density of M2 plus will decreases because charge density is charge over size, charge over volume. Your charge is the same, but your size get bigger and bigger due to more shells being filled. Therefore, your charge density decreases. Your M2 plus becomes less polarizing. Your cation polarizes the anion, so they become less polarizing on the anion, which in this case is hydroxide, because this question is specifically asking you on the hydroxide. Okay, therefore the OH covalent bond is less weakened due to it being less polarized. Okay, if that is true, therefore the MOH twice, meaning the group 2 hydroxide, become more difficult to break down, more difficult to decompose. They're asking you on thermal stability, so I've started by explaining first, but now I will state the thermal stability. So if they become more difficult to decompose, therefore the thermal stability increases because they become more stable to heat, they become more difficult to decompose down to group 2. So the thermal stability group 2 hydroxide increases there. Question 1, part B, you have KSP. So the second part is asking you on KSP. The first part is asking you on the dissociation of the calcium hydroxide as a solid. They said dissociation of these as a solid in aqueous solution. So if I plus aqueous, meaning in a large amount of water, it's reversible because not a lot of it is soluble, only some of it are soluble. Hence we are talking about KSP there. They want you to include stat symbols because there's the idea about KSP that a sparingly soluble solid dissolved in a large amount of water, only a certain amount goes into the solution. So these are aqueous and aqueous. In terms of stoichiometry and balance equation, they need to follow the formula of that calcium hydroxide. You gotta have that symbol because the question asks for it. In part 2, they are asked to calculate the solubility. So if I want to calculate solubility, I need to think about what solubility actually means. The unit of solubility there is mole per dm cube. That means how many mole of these dissolve in 1 dm cube of water. So if the solubility, meaning how many mole of calcium hydroxide dissolve in 1 mole, or how many mole of these dissolve in 1 dm cube of water, if x mole per dm cube, that would mean that, oops, they don't use per dm cube, they use dm minus 3. So clearly I've been teaching year 9 chemistry for too long. Anyway, so if I have 1 mole of these that dissolve, I'll get 1 mole and 2 mole of these. If I get x mole that dissolve in 1 dm cube of water, therefore I'll get x times 1, because 1 mole give me 1 mole, x mole in 1 dm cube give me x mole in 1 dm cube. And this one, 1 mole of these give me 2 mole of these. So x mole of these dissolve in 1 dm cube to give me 2x mole of hydroxide. So ultimately, so Ksp is equal to the calcium 2 plus concentration to the power of 1, because the number in front of the balance equation is 1, multiplied by the OH minus square, because the power in front of the power to which you rest the concentration is the stoichiometric number in front of the balance equation. So what happened there is, I think it's best if I actually move this to a new page, because I think instead of saving up the space, it's better if we fill up the space there. So what happened then is the solubility product is written in such expression. I just need to put in the value. So the calcium 2 plus has a concentration of x, OH minus is 2x. Don't forget, the square is for the whole thing in the bracket. So a lot of students forget that it's the 2x, the whole thing square. They just write down 2x square, which is incorrect. I'll just write down Ksp first without putting in any value. So that will give me 4x cubed. So x cubed equal to Ksp over 4. So I can get x equal to the cube root of Ksp over 4. Now I am ready to put in the value. So there is 5.02 times 10 to the power minus 6 divided by 4. And there's the cube root. So press down to your calculator. Divided by 4, I get 1.255 to the power of minus 6. Don't forget to cube root that thing. And I would have gotten 0.0107865. I don't need that many significant figure. Looking at the data they have given us for Ksp, 1, 2, and 3 significant figure. So back in AS under the first topic in calculations, they say candidates should be able to appreciate what is appropriate number of significant figure based on the data given. This is 1, 2, and 3 significant figure based on the data given. So I will run this up to 3 significant figures. So I look at the fourth one, which is more than 5. So there's 108 mole per dm cube. This is how much of the calcium 2 plus ion dissolve in 1 dm cube of water. And this happens to be the same concentration of these. So the solubility is going to be the concentration of calcium hydroxide, which is x. So we're looking at the answer. Solubility, well, let's say calculate whatever. So the solubility is equal to 0.0108 mole per dm cube as your final answer there, which is going to be how much of these dissolve in 1 dm cube of water, happen to just be x there as well. Part 3, so it's quite a straightforward question, so I'll probably just do it on this page. We're thinking about how it would vary compared to solubility in aqueous sodium hydroxide. So what happened then is we are looking at this equilibrium. If I just very quickly show you again. So you have this equilibrium, which is due to that calcium hydroxide not being very soluble. But then you also have NaOH, which is completely soluble. So what happened then is when you have aqueous sodium hydroxide compared to just in water you don't have this extra OH minus contribution. So what happened then is in the presence of OH, or in the presence of aqueous sodium hydroxide, there are more OH minus. So there are more OH minus ions in the equilibrium. So together, they're existing together, because the amount of OH minus from here is full dissociation, is going to far exceed the amount of hydroxide from there. And because now you have more hydroxide in the equilibrium, what will this system do in response to the increase in OH minus concentration? So OH minus concentration increases. What will equilibrium do? That is to do with Le Chatelier principle. Therefore, the KSP equilibrium will try to decrease. It will try to decrease OH minus concentration by reacting more OH minus. So it will shift to the left side. When you shift to the left side, you are making it becoming less soluble. So you will precipitate out the solid, because as you go from left to right, you're making it more soluble. So as you shift to the left, you will get more of the solid. Therefore, more of the calcium hydroxide will precipitate out, meaning to say you will get more of the solid coming out. So therefore, solubility of calcium hydroxide decreases. They say suggests how it would vary compared to in water. In water, you don't have these, so the solubility of calcium hydroxide in aqueous sodium hydroxide would decrease, will be lower. In aqueous NaOH is lower, or the solubility decreases. Okay, so I think that's the key to that question, really to think about the Le Chatelier principle in terms of more OH minus ions as a result of full dissociation. Because it's a strong base, it dissociates completely. What happened to the OH minus concentration? What would the KSP try to do? It will try to decrease it in response to the change in the system. So that's the end of that 7-mark question there.